Hello there, welcome to this Shieldia guide where I will walk you through the damn vulnerable web app cross-site request forgery from the red team perspective on low security. This isn't going to be a long red team engagement due to the constraints within that the vulnerability allows for, shall we say, it being a cross-site request forgery for a password change. We're going to hit up the blog at shieldia.co. You're going to need the prerequisites, so if you want to follow along at home from either the red or the blue team perspective. In the red team section of this video, we will only be covering red team related stuff, and that is perfectly fine to do if you've got a machine on Hack the Box or TryHackMe on any other providers, or you've downloaded one from VulnHub or whatever. Doesn't matter. Or you've just spun it up directly from, and you're feeling brave, directly from GitHub. Then the red team perspective will be perfectly fine. However, the blue team perspective will bring up the SIEM and all of the other related infrastructure so that you'll be able to look at this activity, and it's going to be a bit more of an in-depth or a bit more complex version of the red team, of the blue team. So what is the cross-site request forgery? What we're essentially doing is making requests within the web application that shouldn't be able to be made from different sources within that application. Here I've given an example of a nuclei template that changes the user's password or whoever's logged in at that time with the valid PHP session ID. This is one that you could chain with some other vulnerabilities, but we're not going to look at chaining it in this instance. We will take, for instance, the user leet, and then if we sent them a link to the password change form, it would then change their password for them. We can have a look at that if we log in. So I'll log in with the admin account. We're going to do that. The cross-site request forgery. We can then, under our low security, input a new password here. You'll note, not like all of the other sites that you've interacted with in your life, it doesn't have the what is your current password. So there's a big glaring vulnerability in that sense, or programmatic weakness in that sense. Goes against best practices, because I mean the pillars of what do you know, what do you have, all of that sort of stuff sort of fall away here, because you don't need to know anything, except you will need to have something which is a valid PHP session ID to be able to do these attacks. So here we can say a new password to be ASDF, and then you just confirm that password, change, and then you can see here within the URL it has changed the password, and you can see it's printed now, password changed. So it's just done a basic GET request to the web server with that specific query parameter and gone, oh, new password, and then password confirmation, and then changed, and then it's changed the password. So if I try login again, we will be greeted with a incorrect password if I tried the normal admin and login failed. But if I tried admin and ASDF, the password would work. We're going to change the password back. So now it's back at the original value, and that's really the meat of this vulnerability. I've then tried to take that and actually do something a bit more meaningful with it. In this instance, there is an exploit, well, not an exploit, there is a method by which you could obtain the session tokens from Firefox. So with a bit of bash and curl magic, we can then, using the cookies database that Firefox provides, we can change these passwords. In the introduction to this post, there's a bit of a preamble. Chrome encrypts all of the values in the cookies database, and I wasn't able to, in the afternoon I spent, decrypt it successfully from a closed cookies database session. There is the dev tools where you can interact with it when the browser is open. However, under Linux, I wasn't able to get the decryption working correctly, seamlessly. So therefore, we'll instead target Firefox, which uses the old method where the values within the cookies database are not encrypted. Anyone can read them. So there's a bit of a weakness there, room for improvement, shall we say. So with a bit of bash and a bit of curl, we can then change these sessions, change the passwords with this CSRF exploit. So we can look at, I'm now the elite user that has logged in. I'm going to set my security to low just so that it's done something. And then there's 100% that cookie in the database. Now we can take a look at the script. So this is using the redirection from cat sort of trick, where you can say, you can give it a multi-line file and then give it a termination character or the end of file, and then it will read all of the preceding lines into that file from the terminal. So it's a bit of an easier way if you have a multi-line file. Instead of doing echo each time or anything like that, you don't need to do that. There's this multi-line, which is really great. So we can copy that and then paste it into wherever in the terminal you are at the time. You'll also note that these are backslashed because you don't want them, you only want them to be filled out. So you want them to be not recognized when you paste it, but recognized when you run it. So you have to backslash it to escape it. Now you can make sure the bash cookie jar has what we want in it. So we can tell it to look for the profile directory in the user's home directory, which is the tilde will always be that specific user's home directory. To verify, I'm just going to go cd into temp, and then there's two ways I could get back. There's cd into tilde, which will take me back to the home directory, and you can even see here it's printed out the that we're at home. I can print the current directory and prove that to you. However, there is another way that I quite enjoy. You can do something similar with Git as well if you're in branches. So you could do cd and then just a hyphen, and then that will take you to the last directory that you were in. So that's got like there is older, I think, in the env, but we don't have to worry about that. We can just use hyphen, and then that will take you back to the previous directory. So if you just want to quickly look around and then go back to the previous directory, that's one way to do it. But suffice it to say, tilde will always take you home. We have the tilde, and then because it's a dot file, because it's hidden, the Mozilla Firefox, and then we're looking for the name cookies.sqlite, which is the database file, and then we want to print that so that it can become that variable there. Now we're saying, okay, with that variable, copy that to the current working directory. Also copy if it has the wall or the shim. Then the next step is using SQLite3. You open the database and then you do a checkpoint. Finally, you open the database and then you get this as well. Can only happen when Firefox is closed, or else you might corrupt the database if two things are trying to access it at the same time. But here, that's why we're just doing a copy and we're not directly accessing the database like you'll see later on. Now select value from the cookies where the hosts is like that, and then the name is like PHP session ID, then that will bring out the PHP session ID for us. So we can now, I believe the next step is to run the script. So now we will run the command. Again, we're doing a locally scoped variable PHP session ID to the shell instance that you're running equals, and then similar to the command injection, you'd have the $ open and close parentheses will run that within a subshell in the current instance of the shell that you're running. So we can quickly run that now. We can echo what PHP session ID is, and it does equal a value, and if we are lucky, that is a valid PHP session ID. Finally, there is a curl request, similar to how we've done logins with curl before. However, there's some key differences. We have the curl, and then we want the output just to go to dev null because we don't care. We want it to follow redirects. We want to set the cookies to security low and then our PHP session ID, but this hasn't been set like it does in other instances where we log in with the admin user and all of that. This has been set by the cookies that we've robbed from the cookie jar. And then you give it the URL that you're targeting, in this case, the CSRF subdirectory. Now, here it should be, my new password should be ASDF. So, down on a web app, and then you have to log out. 1337 ASDF. Boom. And I mean, it was, the Firefox was open at the time, so you could corrupt the database that way. You should really close Firefox, but you've seen that it successfully changed it from Charlie to Leet, to ASDF for the Leet user. So that's one way an adversary might, through an exploit like this, where they're able to change passwords, just obtain a valid PHP session cookie from you and then change the password for your specific session. It's a bit of a louder attack because then you'll log in and go, oh, what's my password? But this is one of the methods that can be employed to change your password. And that is all for the red team perspective of this. I mean, I know it's quite short, but there isn't that much with this vulnerability in the red team perspective at the moment. Moving on then to the blue team perspective, which I will see you in a little bit. Hello there, welcome to this Shieldier guide for the damn vulnerable web app cross-site request forgery on low security within the Tartarus lab. Ooh, seems like I've got the wrong hat on. From the blue team perspective, today we will be covering how we can use tools like the Atomic Red Team to be able to automate this activity within a Windows environment. So you're going to want to have the blue team perspective of this lab already running on your host system if you meet the minimum system requirements. As well, we're going to utilize a further 4 gigabytes of system memory because we need to bring up a Windows machine. That Windows guest will then provide a test bed for how we can test the Atomic Red Team interacting with the Firefox cookie database. So now here it's just briefly explaining some preamble. We're going to want to bring up the Windows host. And the way that I've scripted the Tartarus lab, you can add hosts to the lab once it's already running, as opposed to you just get one shot. That's not really what I wanted it to be like. So instead you can run this command, hosts equals Windows. That then specifies to the Vagrant file which particular host's provisioning should be run on. Then Vagrant up Elastic and Windows, and you have to pass the provisioning flag again so that it can bring everything up for you. Again, from the terminal you ran Vagrant up from. On your host system, you're going to then want to run that. And now it'll go ahead and, because my Elastic instance is already running, it's going to do some checks. Go, okay, cool, that's already there, so I'm not going to make any changes. Then there's an inline script which is checking to see if the Elasticsearch service is running. If it is, no worries. And then if you've passed it a hosts variable flag, it'll say which hosts, which add-ons should be installed, so that we can package these things nicely within the Kibana instance. Then here, okay, well, here it's going to download one of the boxes from the Vagrant Cloud, and it may take some time, so I will see you in a little bit once that's done. Now that the Windows host has been successfully downloaded and provisioned, we can test in Elastic whether or not it is there. So you're going to want to log into the Tartarus Elastic instance. Again, setting the correct hosts for your hosts file. We can now look under the fleet section, and it will bring up all of the agents that have connected back to the fleet server. We can see here the Tartarus Windows agent has successfully connected back, so it has been provisioned correctly. Moving to the next step, we just done that. So you're going to want to RDP into the Windows guest. You could use either if you're running from a Windows host, the built-in RDP client. However, if you're on a Linux host, you will need to use the X-Free RDP. You can access it either via the Kali instance, or you can access it via your host system, which is normally how I would access it. So X-Free RDP, then you have to set some parameters so that the certificate warnings and stuff, and then the password would correctly set up. But there you go. Now we've successfully RDP'd into our guest. We can now briefly install Mozilla Firefox. So I'll be back once it's installed. Now Firefox has been successfully downloaded and installed. You can follow the guide on the Shieldia blog. We can now just close it so that it's available, and then the Atomic won't freak out that it can't find it. We can now go back to the blog, open up a PowerShell window, and then because we're using it via the Tartarus lab, the invoke Atomic will work successfully. So we can search for PowerShell, open it as administrator. You can run this invoke Atomic to get the prerequisites, which the SQLite.exe is one of the prerequisites you're going to need. As stated previously, right click into a PowerShell terminal or PowerShell window, and it will paste it into the terminal. Now the Atomic Red team is downloading those prerequisites for us, the SQLite3.exe, so that it can read the SQLite database that Firefox creates with all of the session cookies. Now we will invoke that Atomic with the invoke Atomic command. And then you give it the specific test that you want to test, as in the MITRE ATT&CK ID. Then you're going to give it the test number that you want to test. So we're going to test number 1 in this case. Done executing, exit code 0. Awesome. So that looks like it has successfully tested. Now we can run a search in the Elastic timeline tab. So moving over to the window where you've logged into Elastic, you're going to scroll down, and then under security, open timelines. We're going to create a new timeline. This new timeline will be a correlation type so that we can use the ESQL. We can then copy out this ESQL and paste it. And then this will give us information. So to break it down, anywhere process name SQLite or process executable like SQLite or SQLite3 and process command line like Mozilla Firefox profiles, app data, and some of the stuff where it would look for these SQL databases, and process command line cookies.sqlite, places.sqlite, form history, or the web app store.sqlite. This then gives us a breakdown of all of the access to that SQLite database. We can then see here in the analyzer the full process history. So we can see, okay, the process arguments were invoke Atomic that then spawned the specific conditions to read that database file. So this is one way you can easily, idempotently test for this type of activity. So we're not using, like we did previously, the bash script. Instead here, because we're on Windows, we will be using the Atomic Red team. A more detailed introduction is within the purple team section of this video. Moving back to the blog, we have some Sigma rules to be able to detect this activity. In this case, one single Sigma rule that is used to look for this suspicious process activity within the Windows host, or within the Windows guest even. Here within the Alerts tab, we can see Sigma SQLite Firefox profile data database access has successfully alerted us for this potential access. So then you can go in and investigate what access has been done and all that good stuff. And because it is an EQL rule, we get the analyze event to get some more context as to what has happened. But we can close the analyzer. We don't have to worry. If you didn't have a seam, how would we detect this activity? In, as it says, a similar vein to the audit D processes, there is a sysmon application that Microsoft provides that has a very powerful logging capability for your specific endpoint. There are rule sets that are provided. There is the one that I use provided by Florian, which is the maintained version of the Swift on Security rule set. It is very powerful. It is really, really good, and they do keep it up to date. We can then, in the start menu, there's two ways we could look for this activity, because the default Windows logging doesn't provide channels for this activity that we're looking for today. So instead, we can use the, as long as you have sysmon installed, which is already installed for you if you're in the Tartarus lab, we can use the event viewer to be able to view this type of activity. Right click, run as admin, and then it should present us with this amazing, wonderful, absolutely astounding search box. I've had my fair share of dealings with this. It is, yeah. We're going to look for the channel applications and services, logs, Microsoft Windows sysmon operational. So that would be Windows, I believe it's in the, no, it's not custom logs. Applications and services, Microsoft, Windows, sysmon. Make this full screen just so that I can see it a little bit better. Sysmon operational. There you go. So in this log, in this channel, there should be the event processes that we're going to be wanting to look at. You can do this, filter current log for the event ID 1, which is process create. And then you have to sort of manually go through to look for the activity you want to find. Not so great, not so great. We can demonstrate that now. Run a filter current log for any time Microsoft event ID 1. Now these are all the process creates. Then in here, you can further look for what command line was used, like what command line args were used to then create that process. So here we can see it's Mozilla Firefox, ping sender. You can see in the details tab, you can go through. We're not going to do that. Instead, there is within the PowerShell window, you can use a search like this. So a get win event for our the specific activity that we're looking for today. Again, just right click with that copied in your clipboard, and then you should see, so the search here, get win event, log name, so that's the channel we're looking for, the filter XPath for event ID 1, where object, match like this sort of regex structure, and then for each object, print the message. See here, the process create, there's the image that created it, or the executable that created it, and you can see some more information here, hashes, all of that good stuff is all contained for you here just via the command line. No GUI, UI, no thank you very much. And that is all for the blue team perspective. moving on, we can look more closely at how the atomic red team works and how you can use that to bolster your environment. So for the purple team perspective, hello there, welcome to this damn vulnerable web app cross-site request forgery challenge on low security from the purple team perspective. As promised in the blue team perspective, I will be discussing how the atomic red team functions so that you can gain a better understanding as to how it is used, how it's deployed, and then how you may use it in your environment. The atomic red team works both on Linux and Windows. The Linux functionalities are provided by an updated PowerShell, the open source PowerShell module, where it can run cross-platform on Windows or Linux. However, my experience is with the Windows edition, so your mileage may vary. The atomic red team is deployed into the Tartarus environment using this provisioner script here. This is an invoke expression and then invoke web request for the install for the atomic red team, then the install and get atomics that will set everything up for you within the environment, so you don't need to worry. If you wanted to copy this same template to be used in other environments, you're more than welcome, but that's how it's installed in the Tartarus environment. Now, the IDs are MITRE ATT&CK IDs. That is how the atomic red team maps all of the tests that it can perform. Here, for example, this rule that we looked at earlier in regards to the creation of a hidden user on a Windows system, it has a reference to an atomic red team test. If you follow that reference, you will be greeted with a page on GitHub like this, where it describes the ID of the test and then the name of the test, and then a brief description from MITRE ATT&CK, then all of the tests that it can perform. In this instance, test number 2 is what we will be looking at. The create a hidden user just called the $, which will be hidden in the login screen. It runs these 2 commands in the console via command prompt: net user $, and then the password add, and then active yes. Secondly, if you run the cleanup command, it will just delete that user and then throw standard error to standard out. The test is comprised of a YAML file and a markdown file. The markdown file provides a user or human readable format. The YAML file then provides how the atomic red team is supposed to execute this test. As we can see here, the name, create, an auto-generated GUID, a brief description, and then supported platforms, in this case being Windows, because it's using the command prompt to run these executors, and then the command to run the test, and then the command to clean it up. So it's quite a robust framework. If you wanted to create your own tests as well, you can. Just make sure it conforms with their predefined executors, and you're more than capable of creating your own tests. If you wanted to run some other like PowerShell commands or anything like that, you most certainly can. Now, looking at the nuclei side of it, it is a very simple template. I'm not going to run it, even because there's no real point, because there's nothing in the seam that would be able to detect. All it does is runs the cross-site request forgery for the lead user, changing their password from Charlie to just ASDF and then changing it back again. The execution flow happens like this, which maybe is a bit unfamiliar. It's doing the login, it's setting the security, and then doing the primary request to change the password to ASDF, and then finally changing it back. And then it's all linked together with double ampersands, so that if any one part of the chain fails, it's not going to execute the rest of it, to make sure you're changing it back to a known good value at the end. I'm going to go through, as I've explained, how these templates work. And that's briefly what I've just explained. Then the Omega CLI has a module where you can test for the atomic red team on a Windows guest via SSH. So here it will SSH into whatever target you give it and then run that specified atomic on it that you specify in the config file. We can, since we have a running instance, there are a few more prerequisites that you need to set up. You need the certificate in the right place, and then you need the SSH user and port that is available on. I'm going to briefly set that up now and then see you in a second. Now that you've configured your env file that contains the username, port, and certificate file location for logging in to the Windows host, then you may proceed with the test. I will briefly tailn32.env. So in my instance, these are the settings that I've had to input: SSH username, vagrant, the key file, and then the location. Normally I do a relative path so that it inserts the same as the CA certificate, and then your SSH port, in this case 22, so the default. You can get the vagrant SSH key by looking in a particular directory. It is in most instances in the home directory under vagrant.vagrant.d, and then the insecure private key, or it'll be a directory of insecure private keys, and then it's one of those files normally ending in .rsa. So you copy this key over to the vagrant directory to the Tartarus directory that you ran vagrant up from, and then with that you can then log in successfully. It does not support username and password authentication. It has to be identity file based. That being said, we can run the test. So Python 3 Omega, then config to read from the .env file the specific test. So in this case, SSH atomic red team Windows Firefox data access SQLite.yaml, then the elastic local for the connector, then your target. You have to put HTTP, you have to put a protocol, but even though it gets ignored, don't worry about that. And then D for the debug. Now it will make sure that the YAML file is valid and then run that test against the specified target. The test in this instance to just be run the atomic test. You'll get an error like this. This is not actually an error, it's just access denied to write to the console output buffer, which is perfectly fine because this doesn't have an output buffer, this SSH session, which is fine. We can ignore that. Here you can see we got the prereqs, we satisfy them, and then we run the test. And here now, finally, in the last output, the last section of the output, you can see the alerts that would be generated from this activity, and then a little helpful successful test at the end. So that is all I wanted to cover today in regards to the CSRF from the Purple Team perspective on low security. I hope you've learned something, and I will see you in the next one.